everyone, welcome to Helm of Science. Firstly, I would like to say that I hope all of you are doing well and are safe during this pandemic situation. I hope and pray that things will get over really soon. Today we shall begin with one such topic which plays a very vital role as far as chemistry is concerned, and that is organic chemistry. So the topic we are going to start is organic chemistry. Now, before we start with the topic, I would like to explain one such analysis that I have made from my past teaching experience. Is that, rather, I would say that I have categorized the reaction of students to this chapter into two parts. Firstly, there is one group of students who absolutely love the chapter. Love everything about it, starting from reactions, starting from nomenclature and everything else. And there is one group of students who absolutely dislike the chapter. Now there are two reasons primarily to it. First reason is that they don't understand the chapter. So they completely leave the chapter and do not prepare for it. And there is one category of students who do understand the chapter but then do not develop a liking towards the chapter. And as a result, they too do the same thing, leave the chapter. So today I hope I will help to build in at least some interest in the second half of students so that they do not leave the chapter entirely and learn at least something about it so that they develop interest and do not leave the chapter for their exams. Right? Okay. So let's begin the introduction to organic chemistry. Now, firstly, before starting or getting into the depth of the chapter or getting into the portions which have been included in your syllabus, what we need to know is why is organic chemistry so important, or why organic chemistry has become a major part of the syllabus of chemistry. Firstly, there are two words which you see I have written here. One is organic, right? One is organic and one is chemistry. Other one is chemistry, right? So there are two words primarily here. Now, the part chemistry is something which deals with reactions. Chemistry is something which deals with the chemical reactions that take place everywhere. And why this term? Why the term organic is what we need to know. Why organic? Now, if we go by the English meaning, then organic actually means naturally occurring. I repeat, organic actually means naturally occurring. Now, naturally occurring meanings is that something which occurs in nature naturally. Okay. Now, what do you mean by that? What I mean is the trees, the plants, human body, everything is organic, right? Everything is naturally occurring. Human beings have nothing to do with it. It is a part of nature. It is nature which has gifted all of these things. Correct? Okay. Now, what we need to know is how is naturally occurring word related to this branch of chemistry? For that, we need to know a little more. That is, organic actually deals with carbon and its compounds. Carbon and its compounds. Okay? It deals with carbon and its compounds. Now, carbon is the major building stone or the building block of organic chemistry. Now, how do I relate these two things, naturally occurring and carbon and its compounds? Now, how is carbon naturally occurring? See, starting from the non-renewable sources that we have, coal, petroleum and natural gas, Their fundamental components is carbon, right? Human body. Human body is made up of carbon. Why do I say so? Because the carbohydrates, the fat, the proteins present in the human body are nothing but natural, right? And the building block of these substances are carbon and its compounds. Okay? Food, which is naturally occurring, that contains carbohydrates, which is also carbon and its compounds. Then, if you might have heard of cotton, the clothing cotton. Cotton is also actually carbon and its derivative. Fuels, that is petrol, as I already said, that is also carbon and its compounds. And there are lots of other examples where I can say that a carbon and its compounds form the naturally occurring part of nature, this part. There is no other element for that matter which justifies this word naturally occurring so beautifully as carbon. There might be other elements, I'm not saying that, but nothing justifies the word naturally occurring so beautifully as carbon does. Okay, now this is one such reason why carbon has been chosen to be the fundamental building matter of organic chemistry. Now there are two other reasons why carbon has been named so, right? So for that I need to just clear this. So point number one is that carbon is naturally occurring, right? Now I am using the elemental symbol for carbon because otherwise there are two things. One, it will become very monotonous if I keep on writing carbon more than once. And secondly, it will save time for both you and me, right? Okay. Second, very important reason is the tetravalency of carbon. Tetravalency. Now, I'll come to this. First, just let me write the topic. Tetravalency of carbon. Now, what do you mean by tetravalency of carbon? This word. Now, this is very important. It's a very important word. See, this word is also combined of two different words. One is tetra and one is valency. Now, valency is one such word which all of us are familiar with in our lower classes. What is valency? Valency is nothing but the negative or positive charge that is owned by a particular element, right? When it's a positive charge, it is called a cation, and when it's a negative charge, it is referred to as anion. Now, why this word tetra? Tetra basically means 4. Okay. Now, what does the whole word in the combined form mean? Okay. Firstly, let us see what's the atomic number of carbon. It's 6, right? Now, let us write down the electronic configuration for carbon. Electronic configuration. What is it? 2, 4. Now, in the valency part, you all have studied that when the outermost electrons in the valence shell is the outermost shell, when the outermost electrons are less than 4, then every element has a tendency to lose their electrons in order to complete their octet or duplet configuration, right? So why? Because having 3 electrons, it will be easier for them to lose the electrons in order to attain their stable nearest noble gas configuration, right? Similarly, we had one such definition which said that if the electron number is more than 4 up till 7, then that particular element has a tendency of gaining electrons in order to reach their nearest noble gas configuration. But that time we never discussed what would happen if the number turned out to be 4. Because it is neither less than 4 nor greater than 4. What would happen if the number is equal to 4? Right? We need to recapitulate one more thing, that we had said when the number of electrons is less than 4, there is a tendency to form cations, that is positive charge species, right? Positive charge species. And whenever we have electrons more than 4 up till 7, then the tendency is to form anions, minus charges, right? And whenever there is a cation and anion together, there is a chance of ionic bond. Ionic bond. Right? There is a chance of ionic bond. Now, what is an ionic bond? An ionic bond is something, or an ionic bond is a bond where there is transfer of electrons. These are certain words we need to recapitulate before we understand the word tetravalency. So, ionic bond means a bond formed due to transfer of electrons. Why transfer? Because only transfer of electrons will lead to formation of positive and negative charges. How? If we get to know, see, if we take the example of NaCl, say suppose. Right? Now Na has an electronic configuration of 2, 8, 1, 11 atomic number, and Cl has an electronic configuration of 2, 8, 7. Now, what will happen? Now, let's try to decode or do how this NaCl bond would be formed. Now, Na has an electronic configuration of 281. In ionic bonds, we generally show the outermost electrons rather than showing all of the electrons according to Lewis dot structure, right? So, Na having one outermost electron. Similarly, Cl has 7 outermost electrons. 3, 4, 5, 6 and 7. Right? So, in order to obtain the nearest noble gas configuration, or rather to attain a stable octet and duplet configuration, for sodium, it needs to remove this outermost electron in order to attain the nearest noble gas configuration, or in order to attain octet. How? Because once it removes this outermost electron, then that complete shell has no electrons left. So the previous shell will be considered as the outermost shell and it will have 8 electrons. So we will attain the duplet or octet theory. So now where will this electron go? Now electrons can't fly, right? It can't go here and there. So what happens is this electron will move to chlorine. Like that. Now why chlorine? Because chlorine has 7 electrons in its outermost shell. It needs at least 1 electron to complete its octet. Now I know there will be some students who will ask me, ma'am, why wouldn't the case be that it removes all the 7 electrons? Then also it will that shell will become completely empty and the previous shell will contain 8 electrons. So we will be obtaining octet as well. So why does it need to take the electron? See, losing 7 electrons is way more difficult than attaining or gaining 1 electron. Right? So that possibility of it losing 7 electrons will completely be ruled out. Correct? So when it gets an opportunity to attain the 8th electron from its friend, which is sodium here, in the nearest hemisphere, then why will it want to lose all the 7 electrons that it has itself? It will rather want to take that electron which sodium has already rejected, so as to complete its octet. So what happens in this case is, what finally forms, sodium after losing 1 electron has a charge of +1. Whereas chlorine after losing its, or after gaining the 1 electron, it has a charge of -1. And together they form conglomerately they form NaCl. That is how sodium chloride, or rather ionic bonds, are formed. So ionic bonds involve the formation of ions. That is why it is called an ionic bond. And ions can only be formed if they have either less than 4 electrons in its outermost shell like sodium, or more than 4 electrons up to 7 electrons like chlorine. Now let us go back to what we said about carbon. Now we had said that carbon has 4 electrons. Now what should it do with these 4 electrons? Will it be losing these 4 electrons, or will it be gaining the 4 electrons? Now that's a big controversy. So it has been found, or it has been concluded, that it will neither gain or nor lose electrons. Why? Because it will violate the principles which we had been studying up till now. That the theory that says that less than 4 electrons means formation of cation and more than 4 electrons means formation of anion. That theory will get completely ruled out because we will not be able to justify which path will it take, the losing of electrons path or the gaining of electrons path. So it was concluded that carbon will actually do what? It will share its electrons instead of giving its electrons or transferring its electrons to anybody. It will share its electrons, sharing of electrons. Now what do you mean by that? Sharing of electrons actually means formation of a type of bond which we refer to as covalent bond. Covalent bond. Okay? Now sharing of electrons, how would we show it? See, carbon has 4 electrons, so it either needs to remove those 4 electrons to form the nearest duplet configuration, or it needs to gain 4 electrons hypothetically to form 8 electrons in its outermost shell. What it does is, it shares its electrons to complete its octet. How? Carbon actually does what? It uses its 4 electrons. Let me just show that to you. 4 electrons, outermost electrons, and brings in hydrogen having 1 electron each in its outermost shell. And what it does, it shares its electrons. Now share how? Like this. Now once it shares its electrons, just see, for the time being, just try to believe what I just said, because I have not explained yet. Just wait a minute. Okay. Now let me give you the justification why this sharing is happening. See, without transferring its electrons or without giving its electrons, it has just shared its electrons, right? Now what happens as a result? It already had 4 electrons in its outermost shell. Now it has also shared the electron of hydrogen, this one, right there. Now once it has shared this electron, it will become a part of carbon as well. So let us count the number of electrons now carbon has. That is 1, 2, 3, 4, 5, 6, 7 and 8, the above ones. Right? So it has attained a total of 8 electrons just by sharing of electrons, and it did not have to lose its parents' electrons. So since this unique nature carbon follows, that is why it is one of the most important reasons also, apart from being naturally occurring, that it has become the major constituent of organic chemistry. Okay. So till now we have discussed 2 reasons. One is naturally occurring and second is tetravalency of carbon. Right. Okay, one thing I should mention, how would these bonds look? See, two electrons when shared form one single bond, one bond. So here also there are two electrons shared, right? So it will be one bond. Even here there are two electrons shared, so we will make it one single bond. And here also there are two electrons shared, so this will be one single bond, right? So this is the structure which we get after sharing of electrons, and if we write it in a better manner, we would say that this is a CH4 molecule, and this is the fundamental constituent of organic chemistry. What is the name, if you ask me? The name is methane. Based on methane, we get higher compounds, or rather better derivatives of carbon, which we use in different things. Okay, but the basic fundamental structure is methane. Clear? Now we move to the third reason. The third reason why, or what makes carbon so unique and the building block of organic chemistry, is its catenation property. Now I'll explain what it is, but first let me just write the topic, that is catenation property. Now what do you mean by the word catenation? Catenation basically means to form long chains, forming long chains. Okay. Now what do you mean by that? Forming long chains meaning what? Meaning carbon has this unique tendency to bond with other carbon atoms and form long chains just like that. It can bind with corresponding carbon atoms to form n number of chains, n number of carbon chains, okay, of any length, right? Now, don't confuse the fact that carbon only can form long chains in a linear manner, in a straight chain form. No, that's not true. Carbon can form long chains in any manner, whether it's branched like that, or whether it's a cyclic compound like that, bicyclic, because it's forming a closed ring compound. Okay, so it can either form a long chain or a cyclic compound or a branched compound depending on its choice, and depending on the resources available to it, right? What do I mean by the word resources available to it? Means the kind of reaction environment we are giving. According to that, carbon will modify itself so as to form long chains or cyclic compounds or branch chains, even this one. Okay, so that depends on the reaction medium or the reaction conditions. So let me just sum up what I said till now. These are the three broad classifications why carbon has been chosen as the building block for organic chemistry, right? And this is why carbon becomes so unique, or organic chemistry as a topic becomes so unique in the field of chemistry. Now, I think one question would have come to our mind, that is, why only carbon? I mean, this kind of, we understand the fact that there are 4 electrons in its outermost shell, which other elements do not have. But there is one thing which still is not understandable yet, that carbon belongs to group 14, right? Carbon belongs to group 14. So why not the other elements present in group 14 not used in organic chemistry, or why don't we call them as organic chemistry? Suppose carbon, silicon, germanium and so on is there down the group, right? So why are we only terming this carbon as organic chemistry? Why not silicon or why not germanium? That is a question that should be understood, right? Now the answer to it is, I would justify it with two reasons. One is, the first one being that yes, suppose silicon, if we consider, it does show the tetravalency factor. There is no doubt about it. But the catenation property is not shown. Catenation property is not justified by silicon or germanium or tin or lead, any of the compounds down the group. This property is not justified by any of these elements down the group. Another reason, which is not that important maybe, but it also plays quite a vital role according to me, is that as naturally occurring as carbon is, silicon to lead is not that naturally occurring. Not that naturally occurring as compared to carbon. So, as a result, we will not call silicon and its compounds, or silicon or germanium or tin or lead, as organic chemistry. We will not call it by that term. Yes, it will follow more or less the same properties as carbon shows, since the valence electrons remains the same, that is 4. The valence electron factor remains the same, right? Valence electron is 4, no doubt. But then, still, we will not refer to it as organic chemistry, since they do not fulfill these two criteria. Okay, so this was basically an introduction class to organic chemistry. I hope all of you liked the introduction, because I believe that if we do not get the introduction right, or if we do not understand the necessity of a topic, there is no point getting into the nitty-gritties or the depth of the topic, because that doesn't make any sense. Rather, it only causes disappointment that it is just a part of the monotonous syllabus that has been given to us. So, it's very important that we understand the need of the topic, the necessity of a topic, before getting into the details of the topic. I hope I have been able to build that interest in all of you, so as to why we need organic chemistry, or why is it so important. I hope you enjoyed it. We shall meet in the next video, where I shall proceed with the depth of the topic, starting from isomerism. I hope all of you enjoyed it. If you did, please hit the bell icon, like, share and subscribe to Helm of Science. Take care until we meet in the next video. Okay? Take care. Bye-bye.